All right. So in our sample proportion, if 20% of our population is obese, then that's your p-value for population. We know that the obesity population is 0.20. If 11 out of the 30 people leaving the mall are sampled and found to be obese, so this is our p-hat. Okay? How likely is it that this sample is a good sample for our general population? Or the follow-up would be, is there something about people who are, coming out of the mall that there's some sort of correlation as to why they might be more obese or less obese? This 11 out of 30 is 0.3 something. 11 divided by 30. Can you do that for me, counter, please? Tell me the decimal. 0.36. So clearly our sample proportion is a lot higher than our population proportion. Is it possible that that's coincidence, or is it due to the fact that they were in the mall? That's always what we're kind of separating here. How much is coincidence? How much is the fact that we were in the mall? So you would run a simulation with your population proportion to be 0.20. Your sample size is 30 people, and let's just do 100 simulations to keep it easy. And then we're going to look at what percentage of ours were, is it 0.36? Why do I have 0.37 there? 11 out of 30. Oh, it actually does round to 0.37 up top here. So if we know for a fact, going back to my webpage, sample proportions is up a little bit further. We have a population proportion that we know to be 0.20, a sample size of 30, and 100 simulation. Run your simulation and see how many times did it coincidentally happen that it was greater than or equal to 0.37. 3% of the time. So our statement on here would be that 3% of the time there's a 3% chance that this is coincidental, that we just kind of got unlucky and grabbed more obese people. There's a 97% chance that there's something about, and you could it could be this, big long-winded connection about why people leaving the mall might be more likely to be obese. But at least we can now quantify how likely it is that there's a correlation versus this is just coincidental. So this would be a 3% of the simulations were greater than or equal to 0.37. And our statement would be something along the lines of, it is blank that the people leaving the mall are a good representation of the entire population. Is it likely or unlikely that they're a good representation of the general population? Unlikely. Meaning there's something about them that sways them in one direction. If you want to put very unlikely, you can, because 3% is a pretty low number. And then on the second one, it is blank that there is something about those who go to the mall regularly that correlates with being more or less likely to be obese. So is it likely or unlikely that there's something about the mall? Likely. It's likely that there's something about being at the mall that, has these people more likely to be obese. So it is likely that essentially that there's a correlation here, as opposed to it just being coincidental. That correlates with being more likely to be obese because our mall population was higher. Nate.
Are we going to be able to use these simulations on the test?
On the test, you're going to be shown a picture of the histogram. That's what you'll be shown. So it'll say it came from a simulation. It'll tell you the number of things that were plugged in up here, 100 simulations. It'll tell you kind of what the population proportion used was and all of that stuff. and then you're pretty much going to see where your 0.37, your observation, falls. And then you're going to get your 3 out of your 100, your 3%. Or it might be 3 out of 200, which would be 1.5%. You might have to calculate your own percentage, okay, depending on how many simulations were done. Maggie?
Will that be what it's like on the final, too?
Yep, they show lots of pictures. Yep. If I go back to this just for the sake of pretending, I didn't know that happened. If I go back to this and let's say I stood outside of a bank, okay? Let's say I stood outside of a bank and I got something like, I don't know, 5 out of 30 people were obese. 5 out of 30 is 0.17, which is actually a little bit lower than the general population, yes? So we would look at our simulation and see where did 0.17 fall, and it's really in the bulk of it. So is there some correlation with people at the bank? Probably not. Does that make sense? The bank is probably, fair game. It's a good general representation. There's nothing about going to the bank that makes you more or less likely to be obese. Okay? Or you could count up how many are, this one was lower than 0.20, so you would count how many are 0.17 or lower, and there's obviously a good chunk of them. So the reality is that this 0.17 was lower probably due to coincidence as opposed to a legitimate correlation. All right? The next example is the sample means. So sticking with weight and so on, if the average weight of the adult female population is 150, then there we are. We're giving you the population average, 150 pounds. Then we're going to sample. If the average weight of the first 30 women seen leaving the mall is 152 pounds. Okay, so our X bar is 152. That's our sample. So it's higher, but is it high enough? We have to find out via our simulation. Is it high enough to think that there's a correlation behind this versus just a sheer coincidence? So we're going to run a simulation knowing that the population weight is 150. Did they tell us the standard deviation? No. They need to give you the standard deviation on something like this. So let's just pretend the standard deviation is 2.3 pounds. They would give you that. The sample sizes, we sampled 30 people, and again, let's do 100 simulations. So when I run this, we're going to be looking for, remember our simulation is all coincidental. So coincidentally, how many times was it greater than 152? So if I go back to a different simulation this time, back to my website, this is the sample mean average. Our population mean 150, standard deviation I said 2.3, number of simulations 100, sample size 30. Good. We want to see how many are greater than 152. So here's our sample means. 152, oh boy, never.
You did a population 26.
I don't think that's going to make a difference. Oh, thank you, though. I wonder, whatever, it is what it is. So our numbers are surrounding 150, as low as 149, as high as 150.93. So actually, 152 never happened. So you would just say, and again, if you look at your chart here, 152 is off the charts. So you would say almost as 100% certain as you can get that 152 is higher due to the fact that there's some correlation there. It was not coincidental. There's something about being at the mall that's correlating with heavier people. Yes? if I made a lower standard deviation, I think I would find, or maybe if I made a higher standard deviation. What if I did that? Okay, the higher the standard deviation, the more variation. That makes sense. It's going as low as 147 and as high as 151. If I went even higher still, like a standard deviation of 9.8, now I would see at least a few scores. Now I would see a lot more. So now you're talking, you're towards the outside, but not overly so. So this is, I honestly don't think the Regents will give you something sort of in the middle. I think they'd give you something either way on the outskirts, so you can say, all right, there's a heavy correlation there, or a stronger correlation, or something that's pretty much in the bulk of the middle where you would say, no, this result is not significant. It's probably due to coincidence. Okay? Outskirts, significant. In here, not so. So I would write something along the lines of, it is, what are we trying? It is unlikely, again, that the people leaving the mall are a good representation of the entire population. And again, same thing here. It is likely that there is something about those who go to the mall regularly that correlates with being heavier. Same written statements, really nothing different there. Our chances are a little bit lower, so what percentage? It was really 0%. So this one you might say it is very unlikely, extremely unlikely, whatever. But you don't have to even go above and beyond with that kind of word if you don't want to. Okay. Our experiment here is still going to, I think it's going to deal with weight, but we're assigned randomly to two groups. 15 live with no technology for a year, and 15 live with regular technology access for a year, and all eat the same meal. So we're controlling what they eat. So the no tech group lost an average of 4 pounds, and the technology people who had access to technology lost an average of 2 pounds. So what are they trying to figure out here?
Technology affects weight loss.
Okay, Andrew, elaborate on that. What do you think the logic would be here? Do you think people with technology or without technology would lose more weight, and why?
I think people that are on technology more would not lose weight.
Because they're sitting at home on their couch on their technology. Exactly. That might be what they're trying to kind of connect here. So obviously the people without technology did lose more, and the people with technology lost less. The question is, how significant is that 2 pounds? Okay, and we would have to run a simulation. The problem here is this significant enough to suggest living with no technology? I have to update this because I can't do this without entering data. With this simulation, you have to enter all 15 people and all 15 people and run your simulation. So our observed difference is 2 pounds. Okay? Pretending that we ran 100 simulations, I'm just going to make up what this might look like. So you'd have a curve of some sort. 0 would be towards the middle. And let's say I've got 2 pounds, 4 pounds, 6 pounds difference, -2, -4, -6 pounds different. What would you say if the 2 pounds, the observed, was here? Let's pretend what percentage of the simulations resulted in a difference in sample means of more than 2 pounds. Let's pretend there were 30% of them were greater than 2 pounds. What would you say? Is that 2 pound observed difference significant? Yes or no? No, correct, Isaiah. Good. not. Because coincidentally, that very easily could have happened. So we would say it is, well, the 2 pound observed difference was likely to have happened by chance. Now, had the observed difference been something out in the 6 pound or the 7 pound range, or the -7 or the -8 pound range, yes, then it would have been unlikely that it was by chance. And you could phrase this differently. The 2 pound observed difference was likely to have happened by chance. You could say that the 2 pound difference was unlikely to what? If it was likely to have happened by chance, then it was unlikely to have been induced or caused by the technology. It's like almost like phrasing it as the glass is half full versus the glass is half empty. There's 2 different ways to say the same thing, and they almost seem like opposites because one uses the word likely, the other one uses the word unlikely, but they're talking about different things. It's likely that it happened by chance, which means it's unlikely that it was induced. You can say it either direction. And I think that's part of what makes this confusing sometimes, is that, you know, some people have likely. You have to read that whole sentence to see what is likely versus what is unlikely. Questions, overall questions on these simulations at all? These are kind of the 3 different histograms that you'd be shown on the regions. Okay, so what I have for you now, and we'll just look at a couple of them, is sample questions. All kind of stats questions mixed together. Mason. And I want to first have you try number 3. Read number 3. And I want you to take a good 3 minutes at least on this before I go over it. Expect to read this 3, 4, 5 times. That doesn't mean you're not smart. Raise your hand if you know your choice. If you've already picked your answer. Okay. Okay, on the count of 3, I want you to hold up 1, 2, 3, or 4, based on what you think you would choose. 1, 2, 3. Oh boy. I see all over the map. Oh boy. Okay. Which statement is false? So there are 50 dots here for 50 simulations. The results of tossing a coin 10 times. So this time they got 1 head out of 10. This time they got 2 heads out of 10. Then on another simulation they also got 2 heads out of 10. On another simulation they also got 2 heads out of 10. So 5 heads occurred most often. That's true. Which is consistent with the theoretical probability of obtaining a heads. The theoretical probability of obtaining a heads is 5 out of 10 times. So that is true. So 1 is not correct. Meaning 1 is correct, but it's not the only one that's false. You follow? Okay. 8 heads is unusual. Well, 8 heads happened 4 out of 50 times. So is that outside the middle? Well, 8 heads or more. So 1, 2, 3, 4, 5, 6 out of 50 times. It was even more than 8 heads. That's 12% of the time. So that's not outside the middle 95th percentile. That's within the middle 95th percentile, right? So the outside 95th percentile, if you're talking 50 times, 1 out of 50 is 2%, or 1 out of 50 is, 2%. So you're only talking about the bottom one and the top one that are absolutely kind of outside that 95th percentile. So this is within the middle 95th percentile. So this one is actually the false statement and therefore making it the correct answer. 3 heads or fewer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 out of 50 is 28% of the time. So that's a true statement, which is why we don't pick it. And the last one, 7 heads is not unusual either, as it falls within the middle 95%. That's true. 7 heads is not unusual. It does fall within the middle 95th percentile. Raise your hand if you got that right. Okay, it was hard for me to count because we had so that's not bad. We had a whole different slew of answers. This is your homework, the rest of the sheet, and corrections due Friday.